As I mentioned in the email that I sent out last night, we are going to kind of pause the unit that we were working on in exponential functions. That unit's a little bit tough to do online and without having a teacher in person, so we'll come back to it when we get back from our break. We're going to instead start working on sequences, which would have been another unit we would have done normally later in the year, but we're going to go ahead and jump into it now. This one should be a little bit easier to go through online without me in person. So basically, a sequence is a set of related things. They follow each other in a particular order. We're going to see a couple different kinds of sequences, and these are all applicable to other topics in math later on, but as always, they're also just another way to model data, which is what we're doing with all of our different kinds of functions we learn about in Algebra 2. Okay, so just to start, we're just going to look at a sequence. We're looking for a pattern, right? You've probably done this before in other times in your younger life. If you're just looking for the next two terms in this sequence, basically we need to find the pattern. Maybe I'm adding something every time. So if I looked here, you could add 1. Here I would add 2. Here I'd add 4. That's obviously not our pattern because I'm not doing the same thing every time. So maybe we can think of it a different way. Instead, this is being multiplied by 2. And then you get from 2 to 4, again, I multiply by 2. That pattern seems to hold if I keep going. So if I kept going here, my next two terms, if I take 16 times 2, that would give us 32. And if we do 32 times 2, we get 64. So there's our next two terms in that sequence. If we look at the next one, again, we're looking for a pattern, right? And we want to find our next two terms in this sequence. This one's a little bit different. We've got fractions. This one, it doesn't seem like I'm adding something each time to get to the next fraction. It doesn't seem like I'm multiplying, but there's a pattern in the numerators and there's a pattern in the denominators. And each time we're just adding 1. So in the numerator, we go from 1, 2, 3 to 4. So our next numerator should be a 5. And then the last numerator should be a 6. And on the bottom, we're also increasing by 1 each time. So 12, 13, 14, 15. The next denominator here would be 16. And then the last one here would be 17. So sometimes they follow a nice mathematical pattern. Sometimes we can just use logic and figure out our next terms that way. Okay, so those are just our basic sequences. We've got some very specific types that we'll do a lot with this unit. The first one is called an arithmetic sequence. And yes, it's pronounced arithmetic, not arithmetic, because it's an adjective and not a noun. So arithmetic. This is a sequence where to get the next term in each sequence, you're going to add to get that next term. And that addition factor that we do every time is called the common difference. And we use a d, a lowercase d, to represent that common difference when we talk about arithmetic sequences. So in this first example, we go from 9 to 7 to 5 to 3. Now that common difference can be either positive or negative. So if I go from 9 to 7, the common difference there would be I'm subtracting 2. So that'd be negative 2. To get from 7 to 5, that's also subtracting 2. And so on, from 5 to 3, negative 2. So as long as you get that same pattern every time, you can tell that that's what's happening. So we have a common difference of negative 2. So then our next two terms, again, if I subtract 2 from 3, I get a 1. And then subtract 2 again, 1 minus 2 would give us negative 1. So there's our next two terms. Our next one, to get from one term to the next, again, you're looking for how much am I adding or subtracting to get to the next term. Now this one, we go from a whole number to a fraction, whole number to a fraction. And it's not too bad to think about it, but if you want to make it easier on yourself, I could make these all have common denominators. So I'm going to change the 3, if I put that over 1, and the 6 over 1. If I give them all a common denominator, that would be 6 over 2, and then 9 over 2. And then this one would be 12 over 2, and 15 over 2. Now it's a little bit simpler to figure out what that common difference is, right? So basically, what am I adding to get from 6 halves to 3 halves? Well, all we're doing is upping the denominator there, so we would have to add 3 halves to get to the next thing. And same thing on the next one, from 9 halves to 12 halves, that again would be adding 3 halves. So our common difference here is a positive 3 halves. And then we just add that twice to get our next two terms. So 15 halves plus 3 halves, that gives us 18 halves. And then 18 halves plus 3 halves would give us 21 halves. So there's our next two terms in that sequence. Just an FYI, another easy way to find that common difference, if you can't just kind of look at it and figure it out, you can always do it backwards. So like on number 3, I can take the term 5 and the term 7, and I can subtract those. So if I do 5 minus 7, that gives me that common difference of -2. And same thing on this one, if I go backwards, if I look at 15 halves minus 12 halves, that gives us that 3 halves. So you can always subtract a later term minus the earlier term, and you can find out the common difference that way. So that's another way to look at it. Okay, so that's our first type of sequence, arithmetic. The other type of sequence we'll do a lot with is called a geometric sequence. And that one, instead of adding every time to get the next term, now we're going to multiply each time. This time we have what's called a common ratio, and we use an R to represent our common ratio. That common ratio is just what we're multiplying by each time to get the next term. So in our first example here, from 40 to 20, 20 to 10, and so on. Now remember, the common ratio is what you're multiplying by. So you might look at the sequence and say, oh, I'm dividing by 2 each time, right? But remember, your common ratio has to be what you multiply by. So if I'm dividing by 2, that's the same as multiplying by 1/2, right? So if I'm doing division by 2, that would be the same as multiplying by 1/2. So our common ratio here is 1/2. Okay, so if I do the next one, 10 times 1/2, or divided by 2, would give us 5. And then 5 times 1/2, or 5 divided by 2, would give us, and just write it as a fraction, 5 halves. So there's our next two terms. Okay, so if it's division, just make sure you write your common ratio as a fraction. All right, the next one, we've got some radicals thrown in on this one. Right, so again, you're trying to figure out what are you multiplying this by to get that next term. So if I have radical 6, I would think about radical 6 times what would give me just a regular 6. Well, that'd have to be another radical 6, right? And then to get from this term to our next term, 6 times a radical 6 would give us a 6 radical 6. So our common ratio here would be radical 6. Okay, so if we keep doing that multiplication, 6 radical 6 times radical 6, well, that would make 6 times 6, which is 36. And then again, multiply by radical 6, we get 36 radical 6. And we could keep going from there if we had to get more terms, right? So there's our geometric sequence. So arithmetic, you are adding a common difference every time. Geometric, we are multiplying by a common ratio every time. Okay, so let's try a few where we're just given some sequences and we're trying to decide, is it arithmetic, is it geometric, or is it neither? And then we also want to come up with the terms that aren't in our sequence here. Okay, so again, I'd say one of the easy ways to look at it is, am I adding something every time, or are we dividing by something every time, right? So this one, this is kind of like that same pattern we had in that very first example that we did on these notes. I can see a pattern in the numerators. Those are going up by 2 every time. And I can see a pattern in the denominators. Those are also going up by 2 every time. So I could easily find my next couple terms. This would go up to 11 over 13, and then 13 over 15. Now, but if I think about this, is it arithmetic or geometric? There's nothing, or I guess you could look at it this way. If I did 5/7 minus 3/5, and I got myself a common denominator there, that would be, let's see, 25/35 minus 21/35. So that would mean a common difference of 4/5, right? Yep, or 4/35. So then if I take 5/7 and I add 4/35, that's not going to get me 7/9. The common denominator between those is not even the same. So it's definitely not an arithmetic sequence. I can't add the same thing every time. And you can look at the same thing with multiplying. I can't multiply 3/5 by something and then get the same thing if I multiply 5/7 by the same number. So this would be a neither. There is definitely a pattern there, but it's not arithmetic or geometric because I can't add or multiply by something to get the next terms. Okay, number 8, our next one here. Again, we're looking at what am I increasing it by? Am I adding or am I multiplying or neither, right? So we've got here at this time, each term is being multiplied by 1/2, right? So I think it would be easier if we actually do that multiplication to see the terms. So 1/2 times 1, well, that's 1/2. Our next term, 1/2 times 2, that's just 1. 1/2 times 3, that would be 3/2. And then 1/2 times 4 is 2. So we're looking for our next two terms. And again, the question is, are we adding or multiplying by something to get our next terms? Well, to get from 1/2 to 1, I would have to add 1/2, right? To get from 1 to 3/2, that's another add 1/2. And 3/2 to 2, that's another add 1/2. So it looks like every time we are adding 1/2 there. And if we kept going, this one would be 2.5, which is 5/2. And then plus another half would give us 3. So this one is arithmetic. And we've got a common difference of 1/2. Okay, so that one we could find by adding a thing. All right, our next one. So we've got some decimals, right? So 0.2, 0.02, 0.002, 0.0002. I would immediately notice here that our decimal is moving to the left one place each time, and we're adding on a 0 each time. So this one, we could pretty easily come up with our next two terms. We just got to add another 0. So this next one, we'd want 1, 2, 3, 4 zeros and a 2. And our last term, we'd want 1, 2, 3, 4, 5 zeros and a 2. So if we're adding a 0 every time, moving the decimal to one place to the left, that would be like dividing by 10 every time. Remember, if we divide or multiply, that's our geometric sequence. But when we write our common ratio, we want to do what are we multiplying by. So if we're dividing by 10 every time, that's like multiplying by 1/10. So that would be a geometric sequence. Okay, and then our last one, this one may be a bit of a stretch. We haven't seen this in a minute. We did logs back in first semester, but it's been a while. So as a quick refresher, if you see log base 2 of 2, that means I want to do the base to what power equals this number. So that means 2 to what power equals 2, right? Well, 2 to the first power would equal 2. And then if I did the next one, 3 to what power equals 4, that one's not quite as easy to figure out, right? So maybe the strategy of doing each log isn't going to help us because I don't know what power I raised 3 to get 4. That's going to be a fraction. And we haven't really talked about how to do that. But that's going to be a decimal number, as is the next two. So it doesn't seem like there's going to be a multiply or add rule here. What I do see a pattern is I see a base 2, a base 3, base 4, and base 5. So the bases are all increasing by 1 each time. And then this is a 2, a 4, a 6, and an 8. Those are all increasing by 2 each time. So to get our next two terms, we would do log, increase the base by 1, so base 6, increase the number by 2, so of 10. And then our last one, log base 7 of 12. So we've got a pattern there. but not arithmetic or geometric. So that one would be neither. Okay, so a couple ways to figure out what our different types of sequences are. You can have arithmetic, geometric, or neither. Okay, so now let's kind of look at rules for sequences. So we've got some other vocabulary here. You'll hear us talk a lot about the nth term of a sequence. The nth term just means whatever I say n is, that's the term that I want. We always use a symbol, a sub n. That's a with a little n by it. And that a sub n determines or denotes the nth term in a sequence. So if I have a sequence 2, 4, 6, 8, 10, the first term we call a sub 1, and that first term is 2 because it's the first term in the sequence. The second term is called a sub 2, and that equals 4. It's the second term, and then so on, a sub 3, a sub 4, and so on. If we know the formula for any term in a sequence, that's called the nth term, then we can find whatever term of that sequence that we want. So even if I know 2, 4, 6, 8, 10, if I want the 100th term, if I have a rule for that sequence, I can just plug in 100 for n and then get that nth term. Okay, and we'll do lots of work with this over the next couple days. But to start, we're going to take a formula for a sequence that's given to us, and then we're going to generate the first 4 terms. So a sub 1, a sub 2, a sub 3, a sub 4. And then once we have those terms, we can kind of do what we just did. We can decide, is this arithmetic, geometric, or neither? Okay, so we'll take our first one here. We've got a rule that a sub n equals 1/2 of n minus 1. Okay, so then we're going to go through and find our first 4 terms. So to find a sub 1, that's the first term, notice that I'm replacing the n with a 1, right? Because I want the first term. So if I replace this n with a 1, then I also am going to replace the variable in the formula with a 1. So our first term equals 1/2 times n, which is 1, minus 1. And well, that would be 1/2 times 1, that's 1. 1 minus 1 is, 1/2 times 1 is 1/2. 1/2 minus 1 would give us negative 1/2. So our first term is negative 1/2. Okay, then to get our second term, we do the same thing, except this time we plug in 2 for n. We use the same formula. So then 1/2 times 2, that's 1. 1 minus 1 is 0. And then we keep going. So a sub 3, that's 1/2 times 3 minus 1. So that would be 3/2 minus 1, which would just be 1/2. And then our fourth term is 1/2 times 4 minus 1. 1/2 times 4, that's 2. 2 minus 1 is 1. Okay, so the first 4 terms of this sequence, and I'm going to write them out down here, would be negative 1/2, 0, 1/2, and 1. So this, again, this is a sub 1, a sub 2, a sub 3, and a sub 4, right? That just denotes which term in the sequence it is. Okay, so now that we have each term in the sequence, we can say, is this arithmetic or geometric? Well, to get from negative 1/2 over to 0, I could add 1/2. From 0 to 1/2, again, I could add 1/2. From 1/2 to 1, again, we could add 1/2. So it seems there that our common difference is 1/2, which means that this is an arithmetic sequence. Okay, to find your 4 terms, look for the pattern just like before to decide what kind of sequence it is. All right, let's try another one. So this one, again, we've got our rule. We're going to find our first 4 terms. So to find our a sub 1, or our first term, we plug in 1 for n. So 1 squared minus 1. Well, that would just be 1 minus 1, which is 0. To find a sub 2, we plug in 2 for n. So 2 squared minus 1. That would be 4 minus 1, which is 3. get our third term, we're going to do 3 squared minus 1. That's 9 minus 1, which is 8. And finally, our fourth term, that would be 4 squared minus 1, 16 minus 1, so that's 15. Okay, so there's our 4 terms. So this time we go 0, 3, 8, 15. Okay, if we look for a common difference there, well, to get from 0 to 3, I'd have to add 3. But to get from 3 to 8, I'd have to add 5. So it doesn't have a common difference. It can't be an arithmetic sequence. Okay, for geometric, to get from 0 to 3, well, if I do 0 times anything, I'm still going to get 0, right? And if I look at from 3 to 8 and 8 to 15, I can't multiply 3 times something to get 8 and then also multiply to get 15. So in this case, it's definitely not geometric. So since I can't have a common difference, there's no common ratio, this one is neither. Okay. All right, 2 left here. If you want at this point, it might be a good spot to kind of pause the video, maybe try these last 2 on your own. Be careful about order of operations when you plug your numbers in, but if you want to pause right now and try these 2 on your own and then come back and compare your answers to mine, that might be a good idea just to try them out. Okay, so if you tried them, I'll put my answers up here so you can check. If I do the first term, I'm doing 2. Notice that's an exponent, right? Oops, if I can spell exponent right, there we go. So 2 to the 1 minus 1 over 4. That'd be 2 to the 0 power, so we get 1/4. 0, remember anything to the 0 power is 1. Second power, or second term, I'm going to do 2 to the 2 minus 1 over 4. That'd be 2 to the first, so 2 over 4, which is 1/2. Our third term, 2 to the 3 minus 1 over 4. That would be 2 squared, so that's 4 over 4, which is just 1. And then our last term, 2 to the 4 minus 1 over 4. That would be 2 to the third, which is 8, and 8 divided by 4 is 2. Okay, so our terms there are 1/4, 1/2, 1, and 2. Okay, I can see pretty quickly here that to get from 1/4 to 1/2, I'd have to add a 4th. Here I'd have to add a 1/2, and here I'd have to add 1. So it's not arithmetic, definitely not that. If I want to multiply, if I do 1/4 times 2, right, over 1, that would give me 1/2. And if I do 1/2 times 2, that's going to give me 1. And then 1 times 2 would give me 2. So it looks like this time we are multiplying by 2 each time. So this is a geometric sequence. Okay. And the last one over here, if you tried this one, our first term, again, be careful on your order of operations. -5 times 2 to the 1 minus 1. That 1 minus 1 is 0. Do your exponent first. So 2 to the 0 power is 1. -5 times 1 gives us -5. Second term, -5 times 2 to the 2 minus 1. That would be 2 to the first power. So -5 times 2 would be -10. Third term, -5 times 2 to the 3 minus 1. That'd be 2 to the second power, which is 4. 4 times -5 is -20. And then our fourth term, -5 times 2 to the 4 minus 1. 2 to the third is 8. 8 times -5 is -40. So then we've got our terms of -5, -10, -20, and -40. This one's pretty easy to see. I'm multiplying by 2, multiplying by 2, and multiplying by 2. So we've got a geometric sequence here. Okay, So generating terms, if you've got a formula for the nth term, you just plug in the number of the term, and that gives you the terms for the sequence. Then once you've got a couple terms, you can decide what kind of sequence it is, if it's arithmetic, if it's geometric, or maybe it's neither. Okay, our last little example here, find the next term in the sequence, 1, 4, 8, 13, 19. Again, you're looking for a pattern. It doesn't say if it's arithmetic or geometric. We just want to find the next terms. So look for your pattern. To get from 1 to 4, well, I could either add 3 or I could multiply by 4, right? To get from 4 to 8, I could add 4 or I could multiply by 2. To get from 8 to 13, I could add 5, or I'm going to have to multiply by a fraction. So it seems like it's going to make more sense to do our addition pattern here. It's not arithmetic because we're not adding the same thing every time. But to get from 13 to 16, we're going to add 6. So our next term, we would want to add 7 and then add 8. So, we only need to find one term though. So to add 7, the next term in the sequence, we would take 19, add 7 to it. Our next term is 26. So again, just some practice and being able to find the patterns. Sometimes they're pretty simple. Sometimes you got to try a few things before you actually get what the pattern is. Okay, so there's our first set of notes on sequences. Hopefully not too confusing, and you can kind of figure some of these out. A lot of the same types of problems on your homework. I am trying to keep the homework short since we're doing this all e-learning, and I took off a lot of the review stuff since we just want you guys to figure and focus on this new stuff for today. After you finish your homework, if you're done with it and you feel confident, you can go ahead and submit it. If you haven't seen how to submit homework, make sure you go back and watch the e-learning info video that's got instructions on how to submit your homeworks in OneNote. Or if you have any problems with trying to submit your homework, just please make sure you reach out and give me notice and let me know and I'll help you out. Also, if you have any questions over the homework, make sure you mark those problems. You can always go into our chat room, type me a message. I'm having trouble on problem number 7. Can you show me how to do that one? And then during our live class time, I'll make sure that I pull up that problem and go through it so you get some help on that one. You can kind of either watch it after the fact or be there for the live video. All right, good luck with this first assignment. Let me know if you have questions.